ray diagrams, so with lenses. This is similar to what we do with mirrors, but a couple of important things. One, the light isn't reflected, so it passes through. And the lenses that we use have two C's and two F's because they're two curves put together. This shape right here is called a double convex because both sides have convex surfaces, or just convex lens. And this shape right here, an hourglass, is called a double concave because both sides are concave surfaces. We can also just call that concave as well. So the light is refracted, and so we have to have it bend. So we still have two rays, the first one, and they both come from the top of the object. But this time it has to pass through the lens. So the first ray is going to come from the top of the object and pass to the focal point, either this one or that one. And then the second one, which is common, is just going to go from the center of the lens, top of the object to the center of the lens. And the center of the lens is where the vertical part of this lens intersects with my principal axis. So double convex lenses are called converging lenses because as parallel light comes into it, all the light then bends toward the focal point on the other side of the lens. It converges. So the rays that we use are from the top of the object through the focal point on the other side, and then the pink ray shows that it's going from the top of the object through the center, and this is where I talked about that intersection. And again, where they intersect, you're going to have the image top, and then the bottom of it will be at the principal axis. Now remember that the observer is in real space all the time, and with a lens, the object is on the other side of the lens from the observer. So this actually is real space. So one of the ways to remember which place is real space is with the mnemonic IRUV. So if my object is inverted, it exists in real space. Sorry, my image. If my image is upright, it's virtual. That's why I've been using inverted instead of upside down. We can still use the same lost terminology. So the location is farther, image is farther from the lens than the object is. It's inverted, it's upside down. It's larger than the object, and it's in real space. So we're going to do some practice diagrams with the same 5 points that we've always used, meaning farther from the center of curvature, at the center of curvature, between the center of curvature and the focal point, at the focal point, and between the focal point and the lens. So my first line that I'm going to draw is from the top to the center right there, and then to the focal point on the other side. And then the second one that I will draw is from the top through the center. Oops, that was really poorly drawn. There we go. And where they intersect, right here, is where my image will be. Where they intersect is the head of the arrow, or the top, and the bottom will be at the principal axis. So in some ways it's easier to draw with lenses because I actually don't need the lens there. I just need that center line of the lens and my principal axis. So if I'm going to do lost, my object is, location is farther, it's inverted, it's larger, and it's real. I'm now bringing my object to the center, that's C. Do the same thing, parallel to the center line, and then down through the focal point. Again, this is where graphing paper and a straight edge are really nice. And then from the top of the object through the center of the lens, dead center, and where they intersect is where my object is. So it's hard to see. It kind of looks like it's moving closer in, maybe. It's hard to see with the quality of this. It'll become more clear as I go. between my center of curvature and my focal point. Now I'm not even showing the lens, I'm just showing that center line because that's really all that matters. Unless you really like to draw double convex and double concave lenses, you can just have those two lines there. And here it's becoming a little bit more obvious. They're meeting farther away over here, much farther. So what's happening is that my object is getting farther and farther away. It's still inverted. It's getting larger and larger, and it's still real. So as I go, move my object from beyond the center to the center to between the center and the focal point, my object size is getting larger and it's getting much farther away. Now what happens at the focal point? So we always are interested in what happens at the focal point, because this is where you can have strange things happen. And indeed, the same strange thing happens with this as with the converging mirror, in which there is no image. My lines will remain parallel, they will never meet, and I will have no image. So if you're looking at the pattern, this seems to be close to the pattern of converging mirror. Let's see what happens as I bring it very close to the mirror, to the lens. We go from the top, parallel to the focal point. And then from the top to the center of curvature. And whoa, now the lines appear to intersect right here. And so now my image appears to be behind my object. So it is farther away from the lens than the object is. My orientation is that it's upright, it's larger, and it's virtual. So as I'm looking at it, it looks like the image is floating behind the object. It's weird. We'll show that in class. But those are ray diagrams, similar type of thing. They follow a pattern. And just remember, one of the things that's a mnemonic that's very valuable is that if I have something that is upright, it will exist in virtual space. If it's inverted, it's in real space.